Good afternoon, everyone. I'm very happy to be here to present whatever work we have done in affordable housing. I must say, it's not really a research topic that we in IIT really work on. It so happened that we got a project and we worked on this particular aspect of the things. But it's very interesting. The learnings that we had in the process is very, very interesting. There are a lot of issues. It's not just, I'm basically a structural engineer. I realize when you go to a housing, you can just not rely only on structural engineering, but you have to depend upon many other aspects of the things there, especially when you wanted to control the costs, when you wanted to be much more effective, you wanted to have a sustainable green buildings. There are a lot of issues that we have to address as an engineering community. And everyone is a stakeholder, from the owner to builder to engineer, architect, everyone is a stakeholder. So I'll just quickly go through the problems that we have, okay? Previously, one of the problems that we have in an urban setting is access to the land, okay? So the legislation for that one should be clear, okay? Just one small change, let's say in 50 meters from the sea coast you can construct. That releases so much land for the urban construction. Otherwise in Bombay you just cannot construct. Okay, so that is one aspect that we have to pay attention to. The policy wise, there are certain things that we need to pay attention to. It's not just the technology. Finance is important, and another important thing is the public-private partnerships. Now in affordable housing, previously all affordable housing used to be constructed only by the government agencies or their contractors, okay? And that model is changing, okay? And now anyone can have, you have incentives to do that one. And then you get the corresponding release in the building area things associated with that. So that is something that is happening and that we should take advantage of, okay? High cost of capital is one aspect that is very, very, very important. There are some other things is already mentioned by Mr. Suresh. So I will not pay too much attention here. Accepting affordability has got a different connotation to each one. What is affordable to me is not affordable to others. So, we have to be very creative in giving the solutions. What I personally pay attention to is the structural stability, and what are really important is the other things, okay? They're equally important. If you really look at in the building construction, you have a manpower part, you have plant and machinery, you have materials. These ratios are changing, okay? And they're quite dynamic in a given situation. In an urban situation, even labor is very, very expensive. And the solutions that are being come up at different places are dependent upon the things there. In fact, you cannot take it for granted that the manpower is available to construct, okay? That thing is gone. So that's the reason why we have to go for system housing. System housing means you have to have a little more automation, a little more mechanization, and we have to have the things. If you really look at housing technology, if you really look at that one, you can classify, okay, something related to the formwork, something related to the materials, something related to the construction technology and the construction methods that you're going to have. If you really look at the things, some of these things, you would see some of the tunnel form, large area formwork, precast construction, cold form steel, GFRG things. I'll just briefly go through some economics of that one, very briefly, some productivity things, just to have an overall idea what are the things that are going to be. These are the conventional things, hollow brick block construction. But one of the things that is there is because you're going to have a reinforced masonry, structural masonry is possible. And that is what is going to be economical, relatively economical when compared to the block masonry, because you have to satisfy the earthquake codes. It's quite stringent. Now it has become quite stringent. You have to satisfy for that things there. These are some of the things that you have to do. Shear wall concepts are quite used in most of the places, Now, even for a smaller affordable housing, the wall concept has come. Okay, I'll just give you a few examples that are done in the past. The one important aspect where you actually have a good quality of construction is if you invest in formwork, your productivity levels would increase a lot. Okay, so that's why the system formwork is one of the aspects that we have to pay attention to. Even if you are going for conventional thing, if you wanted to still stick with steel and concrete, you have to invest in some of these things. Okay, there are a large number of things that are available. Now they are also available not for a small project, for a larger projects. They really make sense in making an investment in these things. The other one which is being used nowadays, especially in Andhra and Telangana and other places, is the MIVAN construction for affordable housing. Okay, is the aluminum formwork based system. Whenever you have more than 100 repetitions, okay, of the same thing, it is found to be economical. Okay, in reality, you may get or may not get, depending upon the way you use it and how productive or how efficient your crew is an important aspect that comes into the picture. Now, the thing is, what happens, what I want you to look at here is, where is the, this unit weight, 25 kg per meter squared, is something which I want you to look at that as one of the things there. You can have staircases, you can have window frames, all these things in aluminum formwork. They have to be manufactured, and now you have in India that capability, which can be done efficiently, could be things there. The weight, one of the things is when you have this formwork, you have to, because you are having a full height things, so you should be able to withstand the concrete, concrete pressure. Okay, typically they are designed for 8 tons per square meter. Okay, this is the thing that is done, and what is important is you also need a semi-skilled labor force, because some trained labor force is really required, and the productivity works out to be per person is 6 to 8 square meters per day. Okay, I would just want you to remember that one, because when you are doing the calculations and economics, okay, they will play a role. In fact, when compared to precast, this is quite high, even though it looks reasonable. The precast is almost coming out to be half of that one. So that's why there is a tendency in the market to go towards the precast. But it has other aspects that you have to address, that is the connections and other things that are going to be there. Now, one of the problems that you have to really do is planning. Whenever you use the aluminum formwork here, what is the number of day cycle that you are going to have for each floor level? Okay, you can have 4-day cycle, or you can have a 10-day cycle, a week cycle. So this is just a picture of what happens in first day morning, evening, second day morning, third day morning. This I'm just showing it for a 4-day cycle things there, so that you know clearly what is the productivity level that you are really looking at. Okay. Unless we reach that kind of productivity level, we just cannot meet our housing shortage. Okay, the point that I'm making is that. Okay, that is the. Now, there are a lot of demerits. Okay, if some component is lost or stolen, you are stuck. Okay, that is the aspect that means how you stack, how you do the things is very, very important. Okay, how you store, how you do the things is very, very important. So if some of you are going for MIVAN technology, be aware of these demerits. Okay, then only you can be efficient in delivering for the things associated with that one. I'll just give an example of what has been done in AP TIDCO in West Godavari. This is a typical plan. These are they have mostly 300 square feet to 365, 430 square feet. These are the different components associated with that one. And this is the aerial view, and this is the final delivery things that are there. Now, these are some of the finishes inside. What it tells you is this is one thing that can work, provided you have more than 500 units in a particular site. If you don't have that one, this is not the system for you. Okay. Now, there is another system that is tunnel form system. In this particular case, you need one phase to be clear so that you can take your formwork out, and then you can reuse in the things above. It's just one example where CPWD quarters in Ananagar in Chennai, where CPWD is using for the things. In Bangalore, there are many projects where they have used tunnel form. Okay, and now these tunnel forms are being manufactured in India at a reasonable cost, so they are affordable. Okay, but there will be one phase that is really required to be cleared. For that one, usually people use precast elements to close that one phase that is there, that is being used. Precast is another technology that has been there for long, but the only thing is nowadays you would see more on two-dimensional precast things, not linear elements. These are the things, wall-based things are becoming quite popular. This is just one example of one construction for affordable housing that is done by L&T at Boyewada in Mumbai, where we did the proof checking for the things there. So you can have any number of possibilities of different shapes, different things, different elements. The most important thing in precasting is the planning, because all your services, all your things have to be planned at the stage of design itself. Okay, you have to plan all your electrical conduits and everything. Only then you would get the economies that you are really expecting. Now, there are some examples of lightweight concrete construction. This is a cold form steel housing system. One of my colleagues works on that one. It's quite economical. Okay, you can get for 1,000 rupees per square feet around that one. Most of the failures from the structural engineering point of view, it's near the screw connections between the sheeting and the CFS framing things. That's where the design and things have been improved. And this is also one of the systems that you can consider for the things. Now, we worked extensively on one particular system. It's called the Glass Fiber Reinforced Gypsum Wall Panel System. I'll just go a little bit more on this particular thing, because as a research group, we worked along with my colleague, Prasad, we worked on this particular aspect. So I'll just go a little more details on this particular one. Now, in India, we have a large number of fertilizer waste. It's around 41 million tons from the fertilizer, because we get that phosphoric acid manufacture. One of the things that you get is the gypsum is one of the waste products that you get. There's along the coast, I'll show you, more than 42 million tons of gypsum is available, and they need to be disposed of. Okay, so this is one way you can use that waste material for the building construction and can be used. One thing that you have to note for the gypsum actually takes, for setting time is half an hour. Okay, the entire thing to gain the strength and everything. So in a concrete, if you are using for precast, you take typically a day to produce a cycle. Whereas the same element, if you want to do it in gypsum, you can do it in 1 hour. Okay, so your productivity of the panels and other things are 12 times 1 hour or more than what you get for the precast. Okay, that is one advantage that you would have, and why not we take advantage of it. So one of the problems with the gypsum is it is weak when you have water associated with that one. The technology is there to add some compounds in such a way you get the good water resistance, and at the same time you also get the strength, tensile strength, by having the glass fiber things. So these are the things that have been used, sort of an alchemy, and then you get a wall panel product. You can have a wall panel of size 12 meter by 3 meter high. It will weigh only 44 kg per meter square. So the entire thing is only 1.5 tons. The same thing were to be in concrete. This would weigh 3 or 4 times that particular thing. Okay, so your handling equipment capacity wise, this will be advantageous. Okay, only thing is you have a hollow spaces. Those hollow spaces can be filled very intelligently. That is a part of design with steel and concrete to get the required strength and the durability and other aspects associated with the design. Okay, this is just in one particular site in FRBL, FACT Kochi. There's 7 million tons of gypsum lying around. Okay, it's a lot of things. Imagine you have each panel weighing 1.5 tons, so you can make so many panels. Okay, from this particular site alone, and you keep adding every day 2,000 tons of gypsum to this particular thing. Now, what we have done is this is actually originally the Australian technology that has been adopted, and in Australia you don't have earthquakes, so you have to work out how to make that thing earthquake resistant design. What are the principles that you have to use? How do you go about for that thing? And that's what exactly we have done over the years. We had around 5 PhDs who worked on these particular things. At the end of all these things, we have a construction manual. We have 2 codes, one on specifications, one on building, which is actually most likely it is going to be released on this month 14th. Okay, that part of the piece of puzzle is ready. Because one of the things is, whenever you introduce a new material, new things, people would ask, what is the standard codes or practices that are they available, and how do you do that one? Okay, that part of the piece of puzzle is now ready. Okay, now what we have, this is just an indication of different places which are big circle means you have larger quantities of the things there. And usually along the coast you have a lot of gypsum. In addition, because of this, these are the amount of quantities of things that are available. In addition, you also have thermal power plants because of the desulfurization requirement that is there. You are going to produce a lot of FGD gypsum. Okay, so you can use that one. In fact, NTPC estimates they will have close to around 5 million tons every year that they will be producing in all their thermal power plants. Okay, these are the thermal power plants that are available in all the things there. So they're closer to the economic centers. So if you can utilize that gypsum, then it makes economic sense to provide. Otherwise, you end up providing only near this coast, but not in the hinterland. Okay, so this is one aspect that we can also pay attention to for this particular thing. What I want you to look at is very quickly go through some manufacturing processes. Okay, you calcine the gypsum, you make it into plaster, you add some compounds. It's that mixing is very important. That's the technology that is there, and you also have glass fibers added onto that one, and you have plugs that comes into that one. You pour this gypsum plaster, and then after half an hour, you can lift the things, they tilt it, and you put it in the drying chamber to get the required strength. Okay, afterwards you have to transport and use it in the things there. So and then you can cut it in the factory to the requirements. Okay, the large panels are there, and then you can, if you have a door and window, these things that can be pre-cut, and then you transport, and then you can use that cut things in your things. So what I would show you is we have done a lot of structural engineering things to establish all the parameters. I'll not go into the things there. We also did some embodied energy calculations for comparison. Okay, so one of the things that you look for is the CO2 emission and embodied energy when compared to the conventional things is 50%. Okay, that's the number that I want you to look at as an outcome of this particular research work that we have done. Now, there are some examples of some of the buildings that are there. Only when we are taken as a part of a DST project, we had a demo building construction in IIT Madras. Low cost, that is for the EWS and LIG, 4 units we have built. In that process, there is a lot of learning that we had gone through. We use that as a test things to establish your thermal comfort and all other aspects associated with that one, durability. There's so many other things associated. After gaining some thing there, then one of my colleagues in IIT Tirupati, they're having a new institution to be built. So he decided to use GFRG as for their hostel buildings. Okay, so there is an interesting process because in IIT we have to use only the public institution like CPWD, to bid for contracts and to make all the specifications and everything associated with that one. With our help, we prepared the schedule of rates and all other things associated with that one. They did the bidding, and then they qualified few contractors, and then they awarded the job, and that was delivered. Okay, so I'll just show you some pictures of that one just to demonstrate that for a large-scale project. In this particular case, the 4-story building is a hostel building. There are 5 hostels that are constructed. They are also done at different things because you need 2 hostels very urgently, so they are done. And then other hostels are there. The students didn't complain that there is no noise about the construction, or about the dust. Okay, so when you use a mechanized way of things, you can also take advantage of some of these things. You can take care of things there. So the process that we have used initially for that one is just to ensure that the contractor gives the right quality. We had a model building for the engineering unit to further things there. We made them construct. We ensured they went through all the specifications. They applied them in our supervision. And CPWD is also their first thing, so they have to understand all the processes. They understood that one, and then they went for the wide-scale thing at the same site. So that process really helped in removing all the kinks in, especially in finishes and other things. This after the construction, because there's a lot of innovative things that are there. On top of that one, there is a solar panels that are there, and there is a direct DC connection, so quite energy efficient. That led to a Green Building Award recently given last year for this particular building. Okay, yeah. This is just to give you a quick outline of the things there. I'll just run through some of the projects that we are involved in this particular thing, just to give you an idea of the different aspects of construction that are there. This is the demo building that I was talking to you. So if some of you are interested in, you can come and see in IIT Madras. There's also a YouTube is available. The video is available. You can just have a look at the things there. And these are different aspects of the things there. It is we constructed almost 6 years ago. Even today, it is very nice. The occupants are quite happy about that. So I'll just go through some pie charts of different materials that are used and what is the energy consumption. So I already made a comment about the CO2 emission. This is just to give you all the calculations that are there. Just illustrated, just to demonstrate it is in a way quite efficient in terms of embodied energy or in terms of CO2 emissions that are going to be there. And then we also did the occupant indoor thermal comfort studies. What is important here is the blue line that you see is the outside temperature, and the red line that you see is the conventional thing, and the green line is what you see is the GFRG building. Okay, this got a little delayed thing because it's a better insulator. Okay, so thermal comfort wise, you have an advantage of 2 to 3 degrees from the conventional thing that you have. We did a lot of tests, large-scale tests, computational simulations that are there, that actually brought about all these documents that are there. Okay. These documents are produced after 4 or 5 years of intense research work. Okay, it takes that kind of a time to really deliver the things. This is one example housing project that we have done under BMTPC at Nellore. There are some other buildings that are done there, residential buildings, with the finishes that you want, absolutely great finishes you can get. There are different office buildings, school buildings. That school building was constructed within 3 months, fully functional. Okay, this one also is in Chennai. They have decided from transport all the panels from this one. They found it economical. Okay, and they finished it in 3 months. Okay, for the next session to be ready, it is available. These are some examples, some of the buildings that are there, and these are the Tirupati hostel, the students staying there, and I would stop my lecture at this point of time. There is also one more video that's available on the YouTube, GFRG Continuing Journey. If you look at that one, This Tirupati hostel has been covered a little more in detail. You can just have an understand what are the processes that went by. In all these things, I want to make a few comments. Whenever you want to bring something new to a building things, it's not easy. The processes that you have to do to get it done, the standardization, the certification that you have to do is enormous. Don't underestimate that kind of work. Okay. With our sharing, we shared these ideas with the Minister of Housing as a part of the GHTC that we had talked about, this one there. There is going to be an incubation centers that are going to be put at different IITs. 4 IITs were chosen: IIT Madras, IIT Bombay, IIT Roorkee, and there's one more institution in Northeast. There's one more institution that they have been chosen as incubation centers. The policies are coming there. So anyone who has not anything connected with housing, any improvement, it could be even a software which just does the project management. If you have a right idea, that is going to be there. In that, innovation support will come from these centers, because they will nurture and they will provide for the things there. So if you have any interesting ideas, maybe within a month or two, we'll know all these policies and everything will be out. You can take advantage of, and then you can use us as the ladder of success. Okay. So I wish you all the best, and I want innovation from you. Thank you.